These are the 4 signals which we plotted in phase 1, and as we can see it's at different sampling frequencies. And we also mentioned that as the sampling frequency increase, the signal will be more accurate and will not lose much information. But when we increase the sampling frequency, also the noise is very clear in our signal, as we can see. This is the pole zero plot for our filter given in phase 1, and as we can see there are 2 zeros and 2 poles at the center or at the origin. The number of zeros surely should be equal to the number of poles. If we increase the number of zeros, as we can see 4 zeros, as we increase k from 2 to 4, there will be 4 zeros, and the number of poles also increase to 4. If we use k equals 6, we will also find that the number of zeros are 6 and number of poles are 6. So the stability of the system, as we can see, it's always a stable system. This is the plot of the spectrum of our filter, and as we can see, we can consider as a low pass filter. Then we plotted the single-sided magnitude spectrum of the 4 ECG signals. This is the plot of ECG signal 1. This is the plot of ECG signal 3. This is the plot of ECG signal 4. And as we can see, in all the plots, we take the y-axis as the magnitude and the x-axis as the frequency in rad per sample. If we go back to our first plot, we can see that ECG1 is the signal which we will do the filtering, and my friends Ganesh and Rohin will explain about the filter design. Thank you.
Hello, my name is Ganesh. As you can see, this is the code that we have used to plot out the amplitude spectrum of ECG1 during phase 1. This is the amplitude spectrum of ECG1. As you can see, there are some noises in between the signals. So therefore, in phase 2, we modified the code to produce the frequency spectrum of ECG1. This is the frequency spectrum of ECG1. As you can see, there's a noise at above 40 and below negative 40 Hz. Therefore, in phase 3, we are going to design a low pass filter with Hamming window to filter out the noise that is disturbing these signals. As you can see, this is the code that we used in phase 1 to plot the amplitude spectrum, and this is the code that we used to plot the frequency spectrum in phase 2.
We use Hamming windows in order to reduce the side lobes of the signal cyclops, means the sudden jump at the end of the signals, as you can see in the figure. This is something that we don't want, that we need to remove from the signal in order to get a smooth signal. As for the coding part, we cut off frequency to 40 Hz and filter order to 200. This line is to get the normalized lower cutoff frequency, and this line shows that we are using Hamming filter, Hamming FIR. So this is the coding for the ECG1 signal after filtering, and this is the original ECG1 signal after filtering from above 40 Hz frequency, and and this is for the new ECG1 signal. And for the frequency spectrum of ECG1 signal after filtering, this is the coding for it. And so this is the frequency spectrum obtained, the frequency spectrum of the original ECG1 signal, and after filtering all the above the 40 Hz frequencies, we have obtained the new ECG1 signal, as you can see, without the noise.